Good afternoon, everyone, and welcome to today's National Weather Service Climate Services webinar. I'm Maggie Hurwitz, and I'm joined by Jenna Myers from the Climate Services branch. Today, we're going to hear from several colleagues who worked on a USDA report about climate indicators for agriculture. We'll hear from Meg Walsh from the USDA Office of Energy and Environmental Policy, Art DiGaetano, who's from Cornell University and also the director of the Northeast Regional Climate Center, and Dennis Toddy, who's the director of the USDA Midwest Climate Hub. We're going to be talking about this report that connects climate indicators, those that we know well in the Weather Service, such as temperature, precipitation, and soil moisture, and well beyond, and how they affect U.S. agriculture. So without further ado, we'll start with Meg Walsh. So just before we begin, though, after the presentation, we welcome your questions. So if you would please put them in the question box, we'll get to them after the presentation. And if you have any technical difficulties, you can also put that into the chat box, and we'll try to help you as soon as possible. So over to Meg. Thanks so much.
Yeah, thanks everyone for giving us this opportunity. Thanks especially to Maggie for the invitation and to Jenna for helping organize us. So I'm just going to start off talking about why we did this. Agriculture is a $1 trillion industry when you count derivative pieces of it. So things like food service and textiles. So 11% of the US economy, $1 trillion industry. And it has a very high level of exposure to climate and to weather risk. Yet USDA, we don't collect that data. You guys collect that data. So we're very happy to have this opportunity to talk with you. With this data, adaptations are possible within agriculture, but they really require very local, reliable information in order to enact those adaptations. And they can have downstream systemic effects too that are unexpected. So we're going to talk about some of those. This is a concise set. With this report, we have 20 indicators. And that was by design. Rather than making it encyclopedic, we wanted sort of a tractable number of indicators that we could look at and get a sense of the context, the climate context in which agriculture is operating in the United States. And it's also important to keep in mind that these indicators bubbled up from agricultural needs rather than filtering down from current observational capabilities. So with that, I think we're going to move on, and Art and Dennis are going to talk you through the flow of the report.
There we go. So I guess I drew the short straw on the lay of the land on this one, which is kind of basically, you know, we felt that this was a good diagram to kind of give you the big kind of mile-high view of our indicators report, and actually also kind of, you know, give you the feel for how, you know, looking at ag indicators or ag indicators themselves really differ from the types of indicators that, you know, sitting in the Weather Service you might be more familiar with. So kind of lay of the land here, lots of arrows, but basically the idea is, right, of course, our driver of all of this is climate change, as shown by the big arrow on the left. And then really that feeds into the types of variables, the types of indicators that you might be familiar with in maybe the National Climate Assessment or some of the international effort, you know, basically physical variables. But even if you look at that, they might have a bit of a different flavor than just, oh, average temperature or average annual rainfall or things like that. Kind of the indicators, the physical indicators that were chosen, they were chosen more or less because these meteorological variables had a direct effect on agriculture. And we'll delve into these in a little more detail later on in the talk. But then also coming off of those, you know, really the change in climate can also affect other things that are resulting of that. So kind of maybe next step down the road. And those are our indicators that can either be physical, like soil moisture. Again, that was a tough one. We really struggled with that. It has a very strong impact on agriculture, but we kind of, as you'll see later on, kind of struggled with having a nice long-term record to look at trends. And kind of there, the idea that it's combining a number of these other physical indicators. And then down on the bottom, that where we label those as biological indicators, I would look at these as kind of more overarching. You know, climate definitely has a very direct effect on where certain weeds have their range, perhaps where different insects can survive, but really looking at a broader picture, both over time and over space. Then as you move over to the right-hand side of this graph, would say as you move further over, you have the larger box that says agricultural change. I would argue that those are kind of one step removed from these main base physical indicators. And really they're removed for two reasons. Is, you know, some of them are, you know, kind of a direct impact of the physical indicator. I think the good examples there are the phenological indicators that, you know, are very much rooted in something like temperature, but really bring in a bunch of different variables and really aggregate or integrate how things happen through time. And in a lot of cases here are using the plant species as the indicator or the instrument themselves. And then also notice kind of by these arrows down here, there's a lot of kind of conversation between these changing plant and disease ranges perhaps, and what might go on with the different livestock and crop indicators that we looked at. Might have to deal with what might be going on in insects, or the number of insect generations that you might get in a plant species. And again, that might kind of then feed back on how much pesticide you use. So really here, this is where we kind of go with these indicators and move them away perhaps from your conventional physical indicators of climate change, but look at more of the indirect indicators where climate change definitely plays a role in those. It's something that changes through time, but other factors can be involved in that. And then finally at the end, I would say these socioeconomic indicators really were kind of the first stab at looking in things like that. The group who put together the report, we had lots of conversations about these, but we felt in the end that it was very important to kind of use these, particularly if our idea was to have these indicators, say, drive agricultural decision-making or agricultural policy. So we'll look at one of those in a little bit more depth at the end of the report, where it kind of looks at all the things that might need to go into crop productivity.
Yeah, just to add a couple more things. This is the sum total. We have a list of all the indicators included right here. We're not going to walk through all of them. We've tried to select some that are the most important to you. So what we're going to do next is walk through a little bit of the process we went through, and then we'll cover some of the general indicators. If we don't touch on one that you want to hear about, ask us about it. We can give you a little more information about it, or you can just go ahead and read the report yourself. And Art did a really nice job of laying this out, but really what we're trying to do here is climate is changing things in weather and other parts of climate. So the next part is, so what? What does that mean for agriculture? And this is a first cut at how are we responding, or how are our responses to those changes playing out. That's where we get to the socioeconomic indicators. So I think we can go on from there.
Terrific, thanks. So we're just going to quickly touch on report development. We relied heavily on stakeholder input to make sure that what we came out with would have an application, would be useful in the end. And then there was drafting by the author team in all these different categories, types of indicators: the physical, the phenological, the biological, the socioeconomic, the crop and livestock indicators, where we filled in and really responded to both the stakeholders and the available information. once we had a report, it went through peer review, and then of course it went through federal review as a USDA document. And I guess now you could say we're engaged in some next steps, but there are some other next steps going forward as well. And we're going to talk about those a little bit more at the end. So I'll leave that one on a bit of a cliffhanger. Since we can, it's a finite report, we can only use examples. So how are we going to make this useful to the agricultural community as a whole? These are the folks who are involved. Lots of folks across lots of different sectors. So it may not be a cast of thousands, but certainly it's a cast of dozens from the federal service, but also from the academic world, from trade groups, producers and farmers and ranchers directly. We used folks from mesonets, folks from just across the board to really get this right. So I'm gonna leave that there, and then I think Dennis, you want to talk about what's an indicator?
No, but I got given this one, so I'll take this. Yeah, just what is an indicator? This is drawn directly from USGCRP. What we're trying to get at is it's easy to measure temperature and precipitation and those sorts of things. As we mentioned, we're trying to get at the so what for agriculture. So those things of we're trying to understand, it's something that we can measure, something we can calculate. We know there are things that are happening in agriculture. Sometimes we can't measure them, we can't calculate them, or the data doesn't exist yet. So we had to limit some of those. But in this case, we're trying to improve understanding of trends and conditions. We're trying to connect the community to data and information. How are things changing because of this? Are reliable and robust. That's another thing we ran into in some of the data is we know that there's kind of data there, but it's not good data. It's not long lasting. So we had to kind of say we can't do this one yet. Relates to an underlying system model framework, something that can be used for decision making. Can we take this information, can we take information away from this and people start using this to change what they're doing because of this? In some cases they are without realizing it, but putting something tangible on this is something useful. And then directly calculated from observations, models, whatever. This has got to be reproducible and something we can measure now, continue to measure, which is an important part when we're looking at data, and I think we'll talk about that more later on about what data was used and what data we think we need to do going on. Oh, I got this one too. Okay. Yes. All right. So the other part, clear relationship to climate. There are lots of things that are changing in agriculture that have other pieces of this, but we want to have a clear relationship to climate. Ag, food production systems, food security. We talk a lot in agriculture about production agriculture, but food systems and food security are other issues, and there are a wider variety of issues that become involved there too. Historical context, we tried to make sure that we had 30 years of data as like a climatological norm will have 30 years of data to support this. We fudged that a few times, but that was where we were trying to go. Again, available, well-documented, public records. Not always public records are good documents, documented records available, but tried to do that. And addresses multiple production types and aspects. I'll throw this in here. I think we were going to throw this here. We tried to draw, when we talk about each indicator, we draw an example from someplace in the country. There are some indicators that are very widespread across the country. Other ones are more focused in certain areas. So we tried to use examples to describe indicators for a wide variety of places in the country, knowing that those examples could be done in any number of different places.
All right, so pass the baton here, I think. And so if I, kind of introduce the physical indicators, there were 5 of them, as you can see here on the side. I don't think any of those should be too much of a surprise to the group we're talking about. But again, as I mentioned earlier, these are variables like temperature and precip, and it's really the idea they have a direct effect on the ag production in the food system. So I'm just going to move through, and we're going to hit each of these at least briefly. Meg, can we go to the next one? Okay, so extreme precip. Again, I think the group we're speaking to, this should come as no surprise. We actually kind of, as Dennis mentioned, we kind of highlighted this as an example of kind of things that are going on in the central United States. And I think you'll see from some of our impact and adaptations why we chose that in that part of the world. So kind of how each of these indicators in the report is kind of set up is they all have kind of an iconic graphic that usually pull from the data. So here's an example of basically days with very heavy precipitation. I believe this is 2 inches of rainfall is what we're using in this case. And again, from the available climate record from the co-op stations, we can show a long-term trend from the 1800s to the present. And if you squint your eyes, at least on my screen here, kind of the shorter term trend from 1948 to the present. And really what we see here is these, in both records, the number of these heavy precipitation days have increased in the central US, the Midwest, the Southern Plains, but that trend has become a bit steeper as we move into the more recent period of time, actually 3 times the rate of change from 48 to 2010 is over the entire record. And really, again, if we want to tie this back to what the impact or adaptation is in agriculture, what's the tie? You know, I think typically from the meteorological perspective, we think of flooding in the landscape or urban areas or things like that. But really here in the ag community, that's part of it. Some of that's tied to just being able to get out into the field and do work in the spring. Some of it is tied to compaction of the soil, which affects root growth and root function and overall decreases yield. There's a disease component to this. Basically, fungal type diseases are exacerbated by wet conditions or even splash up from the soil if the intensity is high. And kind of going along with the adaptation, really across this region where we highlight extreme precipitation, there's a rapidly increasing use of tiling systems in the fields to kind of move that water out of the fields and basically drain it away. You can move on, Meg. Nighttime air temperature was our focus for the southeastern United States. And I'll put a shameless plug in for these graphics. They came out of ASOS, basically. They were driven by PRISM data. And what we're showing here is in the southeastern United States, we're looking at the number of nights where the minimum temperature does not drop below 70 degrees as a threshold. And really here, once we get above that, that presents grain filling issues in some crops. It has some reproductive problems in some crops. Basically, pollination is affected. So again, really tying this metric of nights that don't drop below 70 degrees to crop production itself. And I think the place to focus in on is perhaps through Georgia and South Carolina. The areas that are the bright red basically reflect on average 50 nights during the year that don't drop below 70. And you can kind of maybe see in North Carolina and South Carolina at, in the 1950s and early 1960s, that number was about 25. And as we move into the most recent period, that's nearly doubled for these warm night conditions. And then I think we can do the next one. And then finally, at least the last one that I'm going to speak to is humidity. So basically, again, these are station data. And I guess humidity here is kind of the catch-all term. What we're actually looking at in this graphic is dew point temperature. We're looking at summer conditions. And if your Weather Service eyes are really good, basically each of those dots is a first order weather station. So this is the record of hourly data that we needed to pull upon to look at this. And again, you can see the gray dots represent increases in dew point through time. The bigger the dot, the larger the trend. The ones that are kind of edged with the black edging are statistically significant. But really here, this is an interesting indicator not only for its effect on, say, animal stress with something like the temperature humidity index. Also, it's a very major component in fungal diseases of plants, so very useful for that. But really the real neat thing about this indicator, it's almost like a feedback. So if we look at this area through kind of the Midwestern and into the kind of the plains of the United States, a lot of the literature suggests that this increase in summer dew point temperature is actually due to agriculture itself in the widespread implication of irrigation. So kind of here we see the trends being affected by the ag management practices as well. I think it's time to pass the baton to Dennis.
Yes, and one other thing I wanted to add too with each of these is there is a strong tie to published literature. We're not just grabbing data, but we're tying each of these to published literature on talking about each of these indicators. So making sure this is well documented. Okay, the last two that we're going to talk about on the physical side is soil moisture. Soil moisture is one we struggled with. I mentioned earlier about one of our problems was trying to have 30 years worth of data. We don't have 30 years of soil moisture data in very many places. You know, a couple mesonets and a few other places we have some 30 years worth of data, but soil moisture is such a critical one. Often when we talk about precipitation, we're talking about rainfalls, which have impacts. But the critical issue when you're talking about agricultural production is actually what's the moisture in the soil. Because you can have big rainfalls, a lot of it runs off, and not that moisture really gets into the soil. So, you know, therefore, soil moisture is a big integrator. How much water is around? How much water is there for the crop to be able to use? Is there too much water there? As Art talked about, being able to get to field access. So, a lot of plant growth issues, germination of seed, weed, field conditions, any number of kinds of things here. So the data we're showing here is from a scan station in Kentucky, just giving you an example of this. This is one of those that we realize we're limited on, but there is a lot of work being done on soil moisture to talk about how it's changing in the future, and something that we need to make sure that we are addressing as we go along, from excess soil moisture to too limited soil moisture that occurs in many places. Let's go to the next one. Then we're talking about heat waves. Again, we've talked about overnight temperatures. We discuss heat waves from a Weather Service standpoint in the way of human health, which is important. But also extended periods of heat impact livestock, which we'll talk more about here in a little bit, but also have large impacts on crops. And we're talking about heat waves where we have multiple days above certain critical temperatures. And those critical temperatures vary based on what the crop is or what their situation is. But when you have extended heat waves, you can have depending on timing during the year, they can have some sometimes positive, but we talk more usually about negative ones. It's like heat waves that occur during the pollination time of corn, typically, and with the expected issue we're expecting to see with climate change is more of these more intense heat waves that occur during critical times of the year.
Terrific, thanks. So the physical indicators that Art and Dennis just talked about are, certainly the most easily observed and can be most easily monitored. I'm not suggesting that they're easy, just saying that they're a step removed from, in some cases, from the decisions that agricultural producers actually make on the ground. And so this is where this idea of crop and livestock indicators comes in. We know that climate change has already created stresses and changes in crop systems and in livestock systems. Those have been observed. So we've sort of pulled together some of these indicators. Some of them are already in use within the agricultural community. We've listed three here: animal heat stress, the migration of crop growing regions and idealized regions, and leaf wetness duration. In the interest of time, I'm just going to talk here about animal heat stress. Apologies, I got muted somehow. So generally speaking, animals are raised where conditions for them are favorable. And much like with people, animals reduce their food intake in response to heat stress, which reduces their productivity of meat, milk, and eggs. Heat stress can also create oxidative stress at a cellular and physiological level. And at the most extreme, it can increase mortality in livestock. This indicator is a derived indicator. So there is no animal heat stress monitoring network in the world, but based on temperature and humidity, and some uses of this will include things like wind speed and such. But temperature and humidity alone are widely monitored. And with those, you can do the math and you can create this index. So it's easily calculated based on widely observed measurements. The chart here, this is in dairy cattle in Sterling, Colorado. And you can see over time, there's a definite trend in the one-day heat stress index, temperature humidity index for dairy cattle at this location. For dairy cattle, there's a 2.2 kilogram decrease in milk production for every 1 point increase in the temperature heat index. So from a producer point of view, there's an economic cost to this. Across the industry, it's that economic impact is in the billions. So yeah, so that's heat stress.
Hey, Meg, can I throw in one more quick comment on this too?
Please do.
Yeah, the other issue related to this, we've talked about changes in temperature, but in humidity. And humidity is probably a bigger driver of this issue currently in the central US, where you have increased humidity and you don't have as high a daytime temperatures, but you have higher heat indexes because you have warm temperatures with very high dew points. And when you have those very high dew points, meteorologists know you don't cool down as much at nighttime. And that's what adds much more to the livestock stress, is you don't have that relief period that occurs at night because you don't cool down at night. So that you've got a combination effect that's starting to play out here.
Right, the animals can't dissipate heat, and it can be managed in some ways with cover and shade and ventilation. You know, over the longer term, growers might need to shift varieties and breeds and things like that as well. So there's and feed can help as well. So there's a lot in this indicator for sure.
Okay, I'm up next on the biological indicators. Now again, we're moving the next steps down away from the meteorological. The ones that are in this category are, you know, we're talking about plants or animals or other things that are being influenced by temperature and some of those changes, and these affect crop production and animal ag. Weed range and infestation, we'll talk more about that one specifically here. And well, I guess no, we won't talk about that. Changes where weeds are growing is because of, again, overall temperature changes. And some weeds like carbon dioxide better than other ones, so they become more competitive because of this. The example used in that one is kudzu. The location of kudzu is moving northward in the U.S., and we have some other ones like that are apparently very virulent types of weeds that are issues related to that. Insect infestation, we'll talk more about there in just a second. Crop pathogens are talked about with the increased moisture in the air. When you have more moisture, you have longer dew periods. Longer dew periods, you increase your potential for pathogens in a crop. And then, as this is kind of a reaction to this, not a direct indicator, but a reaction to this, is pesticide use because of trying to deal with these kinds of issues related to. So let's go ahead to the next slide. The example we've got here is insect infestation. Insects, there are multiple issues related to insects as to why they're becoming more of a problem. Increased temperatures during the summertime. You have maybe a longer growing season. A longer growing season allows more life cycles of a particular insect in a year. Warmer winters, you have less of a kill off in insects. for good or for bad, this cold weather that's coming down through the central U.S. may not be a bad thing this winter to try to kill off some insects that we're dealing with related to this. So the example here is showing degree days on corn earworm. Many insects react to, you can track how insects progress by degree days, much like you would a heating degree day, cooling degree day, growing degree day, that sort of thing. So, okay, let's go on.
All right, and then the phenological indicators, I think the best way to lump the phenological indicators is they really come down to a timing of an activity, and then basically also kind of synchrony between how things might play out between, in this case, is one of the indicators is pollinators and pollinator management. So basically, are the plants kind of being active and at the right stages when perhaps the bees are in that area? So really here we can break this down into, I guess there were again 5 indicators here for phenology. We'll talk about that timing of bud break in more depth as kind of the one we call out. Again, we said, are the pollinators active at the right times? How are the pollinators kind of moving as maybe we see the northward migration of bloom? Are the pollinators able to keep up with that? There's also some issues there, not like the pollinators are naturally moving. Actually, in a lot of cases with agriculture, the pollinators are put there, the beekeepers are moving their bees there. So again, the idea of kind of keeping that scheduling in sync also comes into this indicator. Winter chill units is a big one, particularly out in California and down into Florida. There are certain species of crops, particularly in California, the nut crops, that require a certain amount of chilling in the wintertime. And chilling is kind of, a sweet spot for chilling is probably temperatures in the 40s. But basically, what we've seen in this indicator going through time is many winters might not be achieving enough chilling for certain species of nuts and fruit crops. And therefore that has a large impact on their growth habits, their production. And again, maybe the agricultural interests in those areas might need to think about changing varieties based on their chill requirements. Insect generations per season is another one, and it's kind of linked with the livestock vectors as well. The idea for insect generations per season is there are some insects that affect mainly vegetable crops that can produce multiple generations in a season, like the name implies. And typically at a northern location like New York, you might expect maybe 2 generations or perhaps 3 generations of a certain insect. But what we see with this indicator through time is there's an additional generation that's quite possible and actually quite common in recent times. That again obviously has detrimental effect on the crop. And then going back to what Dennis says, there's a pesticide application there too. Basically have to deal with a whole nother generation of insects. So you can move on, Meg. For bud break, we chose actually a unique set of data for New York on apple tree bloom. So that's the graphic up at the top. And basically the different colors represent basically 3 phenological stages. Very appropriately, green tip is in green, and green tip is just when the bud starts to swell. And then as the bud progresses, we get this tight cluster stage, kind of the middle photograph on the bottom, and then finally full bloom. So if we look at up at the top with this indicator, we were able to show, these are actually Macintosh apples in New York, that over this observed period of time from 1980 through about 2014, almost a week change in each of these phenological stages. The phenological stages have occurred earlier in the year. And particularly in the north, this has actually impacts on the risk of freeze damage to these crops. Again, particularly in this kind of period of time now where they're blooming earlier, but it's still likely that we'll get zapped by a cold air outbreak in the spring. we actually see an increased risk of frost damage. And the bottom graphic shows with some projection in simulated data that these trends continue basically out through time. Go on, Meg.
Okay, we decided that I was the closest thing we had to a social scientist or an economist of the group, so I drew the socioeconomic indicators. We actually were supposed to have one more presenter, Dr. Eugene Tockley, who's retired from Iowa State University, who was unable to join us, so I'm taking his indicator. And if you remember our graphic, the socioeconomic indicators were all the way down the far right, as in what is changing in climate, what is changing because of climate, and then what are we starting to do about it, and what's happening because of that. And this is something that's going to take a lot more work as we go along, but there are three that, these were discussed a great deal, as we had some social scientists. I don't think we had an economist, we had a couple social scientists in our group, of what is happening on the economic side. There are a number of different things that are happening on the economic side because of what is happening, but it's hard to separate sometimes things because of climate versus not from climate. So the three we have included here are crop insurance payments. Basically, so people quick understanding, there are people pay for crop insurance. Crop insurance is subsidized by the federal government to encourage people to accept crop insurance. So therefore, the risk is we're trying to mitigate the risk by dealing with crop insurance. What is happening in the way of crop insurance payments? There is if you read the report, there's a quick thing. We're seeing increases in drought, largely in the West. Crop insurance payments due to drought, largely in the West, and then excess wetness and cold, which is more up in our area, more in the springtime related to that. Total factor productivity, I'll talk about here in just a second. And the last one is pretty clear, heat-related mortality in agricultural workers. This is obviously a huge concern because a lot of our harvesting activity or fieldwork activity where a lot of our food crops come from are in areas that are, California and the Southwest, where we have more of our heat-related issues that are showing up so far. Other parts of the country, yes, but those are the big areas. And that's something that, it's not only, well, we can talk more about that another time. Let's go ahead and go to the next slide to talk about total factor productivity. Probably the least intuitive of any of these, but the basic idea behind it is trying to assess the productivity of agriculture versus the inputs that are involved in it. And this graphic is showing, the total farm output, which is the red line, but then the dashed line is the total factor productivity is following the total output, while the total farm inputs are relatively flat across the bottom. Basically, we're continuing to increase our farm productivity without increasing inputs. That is something that there is potential concern for over time as climate issues become larger and you have bigger losses because of that, or you see degraded soils or loss of nutrients because of climate issues. Those inputs then are wasted, and we don't see that in the productivity. These are things that we're being concerned about. So far, they aren't showing up, but we're expecting those in the future to be more of a problem related to that. So I think we can go on to the next one, Meg.
Terrific. Okay. So across the board, this is just sort of a sample of the different kinds of indicators, but across the board, we wanted to look at multiple types of effects across multiple production types. So, we've discussed crops, we've discussed livestock, we've discussed commodity crops, specialty crops, and hopefully you can start to see how some of these things relate to each other, right? So apple trees, the information related to apple trees in New York, hopefully that can be adapted to peach trees in Georgia or to apple trees in Washington, right? So we've got a good breadth across agricultural types here. using different types of indicators can be very helpful. So some of these indicators, of course, are closer to the climate forcing, to the weather, the direct weather effects. And some are more closely related to the agricultural outcomes that are of interest. Things like pest outbreaks and some of the other things that we discussed. Another outcome of this report, if there's a well-established relationship between an impact indicator and a well-monitored climate variable, then we can calculate or derive or model or infer or create a statistic to get an indicator for that relationship to help us manage. This issue of data and informational continuity, measurement distribution, and monitoring density is a really important one, and we had to discard a number of indicators that just didn't meet that criteria. And then finally, in terms of conclusions, if you take any of these indicators at an individual level, that will help you with local management decisions in agriculture. But you can also build them up in certain ways, look in geographic areas or look across production types, and that can give you a good sense of the climate context in which agriculture is operating in the United States. Yeah, so for next steps, I know every talk you've ever heard or given, there's been a thanks at the beginning and the end, but in this case, we want to just be really clear that we are very happy to have this opportunity to talk with you specifically, because we need the information that you collect and develop, and so we're just really happy for this to be the beginning of that conversation. And I know that, that Dennis and Art both have more to say on that point, so I'm going to turn this over to them for the moment.
Yeah, I just want to say, I bet you at least half of the indicators basically were derived in one form or the other by NOAA data. Basically, lots of co-op data going into these indicators, where we had indicators that really relied on hourly type things. Unfortunately, without a good record of the mesonet, we had to rely on the Weather Service data there as well. So those types of efforts, really, we need to continue to do that. I guess I'm preaching to the choir, each of you know there, but without that, even though it is a kind of one step removed from the typical climatological analyses that you might see, those data were a key part of it.
But the next steps now are, okay, what additional data do we need to get? And I guess one more thing, we need to support you folks and your data, continuation of data collection, because we still need that data to be able to do this. Otherwise, we could lose some of those indicators as we go along. But then we want to make better application. I talk good. We want to apply this better and use this with downstream users, with stakeholders. So we want to work through our climate services partners, connecting with you folks, and you can share that information with other folks along the line to help people improve their decision making, understanding that we're seeing more of this frequently. So looking ahead, maybe I need to be changing my management to mitigate that. People are probably seeing that sort of thing already. We do have some next steps in how we're going to place this data into people's hands and bring it locally. I don't know, Meg or Art, do you want to talk about that much more at all, or?
Yeah, if I
I'll be. Oh, go ahead, Art.
I was just going to interject kind of under the climate service partners. I think a vision that we all have for kind of next steps kind of takes two different paths, right? With these indicators, hopefully what you've gleaned from our talk is, the indicators are useful kind of almost in day-to-day type operational decisions. So if we take maybe livestock heat, right? That's something that even though our ultimate goal might be to see how that changes through time, so kind of a time series view of that indicator, and able to get to that time series view, we really need to know what's happening each day with that indicator. So really the kind of where we can play off each other and where those two paths are is, if we have to go that route of using these types of models to get the long-term change in the indicator, we also want to make use of the real-time aspects of that, so we could have a tool to maybe go to a livestock producer or livestock handler and say, boy, there is high heat stress today, or even high heat stress forecasted in the next couple of days, based on the same type of calculations that would be used to look at this long-term index.
Yeah, thanks, Art. And I'll just wrap up. I mean, obviously here we've listed a couple of potential indicators that we could also be developing. We said this was a concise set, not an exhaustive set. And so basically we are hoping this is sort of whetting your appetite, that this is the beginning of a discussion and a collaboration going forward. And we hope to talk with you more. And on that note, let me just thank you again. USDA's web services, it's kind of a clunky URL, but if you just Google climate indicators for agriculture, USDA's report website will be right there at the top. And then also we've provided you with our email addresses here, and we'd be very happy to talk with you. We invite additional discussion, and we would welcome it. I want to thank you very much.
Meg, I think we should say one more thing just about the format of the report. All these are in one large report, but they're structured individually. So if you want to share just about this one, it's like a 2-page general purpose. You can pull that out and share it with people. So it's not that this large thing that you can't, it's hard to deal with. You can deal with it individually.
Yeah,
absolutely. Each indicator.
Yeah.
Go ahead, Art.
Each of the indicators is a 2-pager. If that wasn't 100% clear from what Dennis said, that's how we designed it to maximize its usefulness.
Yeah, it should be very accessible to the various audiences. That's what we were hoping for. Yeah. All right, well, thanks so much. And I don't know, are there questions?
There are, yeah. Thank you all for the great presentation and also for making these materials accessible to us. So we do have a couple of questions. I wanted to start and follow up with what Art was saying about sort of time series and tracking the indicators. I was wondering, about how adaptation measures play into this. So I was speaking with a USDA colleague a couple of years ago who said that their family's cattle ranch was, I think, changing the size of cattle that they were purchasing to adapt to more heat. And I know that some farms are planting different varietals to adapt to changing conditions. So how does that affect your tracking of these indicators?
Do you want to start, Art, or would you like someone else to?
I think Art is
Dennis?
muted.
Muted Art, okay.
Yeah, are you there, Art? No, he is muted. Okay, yeah, Maggie, that's a good question. That is something that we are aware of, that adaptation is going on, and probably something we should try to track in these sorts of questions, but the data isn't always there and available, or maybe needs more digging in the available data to be able to deal with that.
Yeah, we have very little. So agricultural decision making takes place on multiple scales, right? So there are near-term adaptations, there are mid-term, and there are long-term. And if you asked a producer, it wouldn't, they wouldn't necessarily be responding to climate, right? They're just responding to the conditions that are in front of them, rather than necessarily long-term changes. So, for example, on the heat stress example, a short to mid-term adaptation could be just to provide cover, to provide shade, or to alter your ventilation system, for example, if you have a poultry house. Long-term change would be to change your herd type, the varieties that you're using, and as we suggested early on, these aren't easy decisions, and they're not necessarily free or even cheap. They're a substantial investment in some cases. So the idea is to inform the adaptation choices that are being made as best we can with this kind of information.
Great, thank you. So I'll turn to some of the questions here, and I believe, Art, we're trying to fix your audio issue as well while we do that.
I'm back.
Oh, good.
Oh, great. So one question from my colleague Richard Hine, who's wondering which of these indicators is computed at a national scale, thinking about the inclusion in the drought monitor and other tools.
Yeah. So how you doing, Richard? It's good to kind of hear you. Yeah, I guess really the idea is for this particular report, none of the indicators are basically computed specifically at the national level, right? The examples are place-based or at the best kind of regional base. However, the idea is that each of these indicators can be computed on a national level. And for some of them, that's easy because the same indicator is useful across the country. In others, it becomes a bit more difficult, like chilling might be a good example of that in fruit crops, where different parts of the country use a slightly different chilling index. So although the base data are the same, the method, the algorithm for computing that is different. And that's really where we expect to go in our next step to address that issue. That's clearly a lot of the feedback we've gotten from this is, oh, you've shown this neat example for the Southern Valley of California, but I'd like to see this in Georgia or someplace else. So that's where we have aspirations of going with that.
I will counteract. Oh, sorry, go ahead, Meg.
Go ahead, Dennis. I think we may be on the same point.
There is one, the TFP, the total factor productivity is considered, the information we use is national for that right now.
Yeah, actually across the socioeconomic indicators, things like crop insurance is a national sort of indicator. It is broken down into regions, but it's looked at the national scale, and heat mortality in agricultural workers looks at the national scale as well. But the idea is to create this tool that Art previously discussed, where we can look at things at as local a level as we need to make local management decisions, or as aggregated a level as we need to make other kinds of agricultural decisions.
Thank you. So there's another question about land use and land use change, and I don't think that was something that you covered. Could you talk about those and whether those would be appropriate indicators as well?
The only thing that comes to mind off the top of my head would be drawing the example from the north central U.S., the northern plains, where we talked about crop migration areas, that the climate has changed enough and they've changed some varieties of crops that we have seen some reduction in rangeland prairie areas to crops because people were trying to make economic decisions, chasing some dollars, and where areas that used to be more better as rangeland could be productive cropland. That's the only one I can come up with off the top of my head. Meg, do or Art have any other ideas?
We kind of touched on that. That was one of the things we went back and forth on, I think, in some of our meetings, where trying to find something like that fit our definition of an indicator. And one of them that comes to mind is, I mentioned with the extreme rainfall tiling, I think we were looking at maybe thinking of number of acres that is tiled as an indicator, but just did not have a long enough data record for things like that as a way of kind of, I guess I'm not quite sure where the question is going with land use, but there I know even in something like the National Water Model, they have a component in there for tiling because it does have a large effect, at least regionally, on the way things are connected and runoff processes and things like that.
Yeah, so one of our criteria, certainly there are conversions between different kinds of cropland and forest land and pastures. As we discussed sort of early on in the discussion, we had to relate everything back to climate. There had to be a specific climate forcing. So, you know, in the case that I think Dennis just discussed, as idealized crop regions migrate, there's becomes an economic impetus for changing your crops or your land use, land cover types, and then we can reflect that in an indicator, and we can, you know, we have to go a couple of steps back, but we can relate that to climate with certainty. But there are a lot of other land use changes that aren't easy to relate to climate, and that don't necessarily relate to climate. And so I think what we'd be happy to do there is to discuss that a little bit further to find out a little bit more about what's behind that question. Thanks.
Great. So I think the last one for today is about applying these indicators. And there was one question about whether these indicators will be used to update plant hardiness zone maps or any other products that USDA produces.
Well, here,
go ahead.
let me take one swing at it. We actually have in the Climate Hub right now, we have a liaison from NRCS, the Natural Resources Conservation Service, actually a couple of them, who are looking at the changes in climate and how they affect some of the NRCS standards. So within NRCS and parts of USDA, they realize these are going on and trying to figure out how we can get those applied to the standards that are used and to make better choices on the standards.
Yeah, a couple of other applications. One is, so this, the sort of the deep roots of this report are through the National Climate Assessment and the US Global Change Research Program. And they maintain a set of climate indicators that some of these indicators we're working to get those, I would say, canonized into that. And then that becomes a larger part of the overall discussion of climate and agriculture as well. Maybe not quite as applied as the questioner was indicating, but that's one of the next steps. The other next step is this agroclimate approach through the University of Florida. So we have a geographically explicit, regularly updated database looking at common, looking at all across the U.S. at all the different geographies over time in a regularly updated way, and then how that ends up being applied. You know, I don't think the report's only been out for a few months. I don't think a lot of consideration has been given to that, but the applications are enormous, particularly when we work through folks like extension, like agricultural extension, like the USDA climate hubs, and also through folks like the NOAA RCCs and folks like that, getting the information out there. Clearly there's a lot of power in this kind of information, and so some of those next steps aren't clear, but it's clear that they're coming.
Another part about that is the next steps for producers are, and I've had this question asked of me, okay, we understand things are changing, what do we do now? And there are some management things that can be changed, but sometimes changing a cropping system is a whole different aspect that producers are not ready to deal with.
Okay, thank you. Well, thank you again to Art, Meg, and Dennis, and for making the report available to us and opening our eyes to new climate indicators that we don't encounter quite as often within the sort of weather and climate realm. So thanks again, and hopefully you'll join us at our next webinar. Thank you.